Hey guys, I'm Rishabh. Today we are going to talk about on a topic adding vectors by components. So, uh, in general, we can add vector geometrically by using sketch, and the second process is by using vector capable calculator. We can add them directly on the screen. And the third way is we can add vector by combining their components axis by axis, and which is the way we are going to talk today. So let us consider a statement r equal a plus vector b. Let's take question 1. Here uh, the equation 1 says that the vector r is same as the vector a plus vector b. Therefore, we can say each components of a vector r must be same as the corresponding components of vector a plus vector b. So the corresponding components of vector a vector r is rx equal to ax plus bx. Question 2, ry equal to ay plus by. Question 3, rz equal to az plus bz. So in other words, the two vectors must be equal if their corresponding components are equal. So from equation 1 to equation 4, a and vector b must follow some steps. So the three steps are, the first one is resolve the vectors into their scalar components. Resolve the vectors into scalar components. And the second step is combine the scalar components axis by axis to get the components of the sum of vector r. So combine these scalar components of axis by axis to get the components of the sum of vector r. And the third one is combine the component of vector r to get vector r itself. Combine the components of vector r to get vector r itself. The step third in step third, we can express vector r in unit vector notation or in magnitude angle notation. So this process is also applies for subtraction of a vector, such as let's take vector d equal to vector a minus vector b, or we can say vector d equal to vector a plus minus vector b. So we add uh, vector a and minus vector v by components to get dx equal to ax minus bx, dy equal to ay minus by, and dz equal to az minus bz, where vector d equal to dxi cap dyj cap plus dz k cap. So to understand the adding of a vector by components, let's take an example. Here we have a question that vector a equal to 4.2 meter I cap minus 1.5 meter ij cap, and vector b equal to minus 1.6 meter I cap and 2.9 j cap, and vector c equal to minus 3.7 meter j cap. So we have to find what is their vector sum, or we can say vector r. So the solution of this question is, for the axis x, we add the x components of vector a, vector b, and vector c. So here we have vector a, vector b, and in this direction vector c, and this is the resultant vector. So for the axis x, we add the x component of vector a, vector b, vector c to get the x component of vector sum of vector r. So x component of r equals ax plus bx plus cx. So when we put the values of ax, bx, and cx here, we get the x component of vector r. Similarly, the y component of vector r, by putting all the value of ay, by, and cy, we get negative 2.3 meter. We then combine this component of vector r to write the vector in unit vector notations, and so vector I equal to 2.6 meter I cap minus 2.3 meter j cap. We can also find a magnitude and angle from this equation. This is the particular answer what we needed to find, which is the required uh, which is required in this question, that what is the resultant vector. So here we have the I cap is 2.6 meter, and J cap is negative of 2.3 meter. So we can also find the magnitude an angle from this above equation, where to find the magnitude of the equation magnitude of vector r, we just need to square root of the component of vector r. So we get 3.5 meter here, and also by using theta is equal to tan inverse y by x, we get minus 41 degree, where the negative sign means clockwise direction. Let us understand the relation between vectors and laws of physics. So let us take a single vector in xy plane. So if there is a xy plane, this is x and this is y. This is ax and this is ay. So the resultant vector will be vector A. So if we rotate the axis by an angle phi, so what we get after rotating the axis? This is x, this is y. We get this is x dash, and this is y dash. We are rotating it by angle phi. So in here the vector component will be vector A, and here this is ax and this is ay. So and this is the angle of theta dash. Here the angle will be theta. So from this graph, or since from this graph we can understand that there is an infinite number of choices of phi, I mean the choices of angle, and so therefore there are infinite number of different pair of components of vector A. We can take the infinite number of this I mean you can take it as any number or any degree, so it will be infinite number. So the question is, which is the right pair of the components? How we can choose a right component for this vector A, that ax ax and ay will be right for vector A. So the answer is that they all are valid because each pair just gave us a different way of describing the same vector A, and also all produces the same magnitude and same direction for all vectors. So from the figure second we can understand that A equal to root under ax square plus ay square equal to root under a dash x square plus a dash y square, and also theta, the whole angle theta, equal to theta dash plus phi. The point is that we have a great freedom in choosing a coordinate system because the relation among vectors do not depend on the location of the origin or on the orientation of the axis. And this is also true for the relation of physics. They are all independent of choices of coordinate system. So that's all for today, and we will meet on next video. And please comment if you have any doubts or any missing point in my video. Thank you.